Okay, this is question number 13, MCQ, Newton's laws of motion. I will read the question first. Length of a 1 meter long uniform spring of mass 50 gram increases by 2 centimeter due to its own weight if it is suspended from a fixed support. How much load should be suspended from the lower end of the spring so that total extension becomes 10 centimeter? What we will be requiring in this question is this concept. I will develop it first. Let a spring has force F acting on its both ends like this. Now mentally separate this spring into n parts. I've shown 5 parts here. In general, it is n parts. And draw FBD of each part. Since the whole spring is at rest, so every part will be at rest. Now consider this lowest part. So this is the force which is acting on the whole spring at its lowest end. There must be an equal and opposite force acting on upper side of this part because it is at rest. This part is at rest because the whole spring is at rest, so every part is at rest. And since the spring is ideal, so it's massless as well, so there is no weight of this part. So this F should be cancelled by the force acting on upper side. And who is applying this force? Obviously this force is applied by the part which is just above it. So from action reaction, the same force acting downwards will be acting on the part just above it. And since this part as well is at rest and massless, so it should also have the same force on its other side, and so on. The story goes on like this. So we see that every part of the spring has the same force as we have for the whole spring. Suppose the whole spring elongates by x, then these parts, since they are n in number, the elongations will be same and such that when they are added, the summation should become equal to the total elongation, that is x. So the elongation of one part will be obviously x by n. If you find the spring constant using the formula F is equal to kx, the k of this whole spring is simply F by x, while the k of this part of the spring, one part of the spring is, suppose k dash, it is force divided by the elongation. Elongation is x over n. F over x is the spring constant of whole spring, n goes upstairs. So we have this result that if we mentally divide this spring into n parts, then for one part the spring constant is n times the spring constant of full spring. So this we will be requiring in our question. Okay, so this is our spring. It is attached to a ceiling and it's given in the question that a spring is elongating due to its own weight. So consider section at a distance x from its lower end and consider this part of the spring and draw its FBD. The weight of this part will be lambda times x times g. I've taken lambda as mass per unit length. So this is the weight of the spring and this will be balanced by a force at its end equal to the same force but in opposite direction. Now we can easily check that as you change the section, the force acting on the section is changing because it is depending on x. So if you take a small part here, suppose of length dx, in dx distance, this lambda x into g will obviously change, but that change will be a negligibly small change. And therefore, we can fairly assume that the forces acting on this dx part are almost equal in magnitude, and we can take as lambda x g each. Now we have to find the elongation of this dx part first. And for that, we need the spring constant of this dx part. And the spring constant we have just found is n times the spring constant of whole spring. And how many parts do we have here? If we mentally divide it into many parts of length dx each, then this total length will be having L divided by dx, these many parts. So this is n here. And since L is 1 meter in our question, so this comes out equal to k by dx. So the elongation in this dx part is simply the force upon k of this part. And you can verify it's so simple. And to find total elongation, we have to integrate this. Now check that lambda into L, this is mass of full spring, which is given as 50 grams. I'm not changing the unit here. So this is the total elongation due to the weight itself. Now, when extra mass of m is suspended at the lower end, then the elongation will be the elongation found earlier. This will be there, and there will be an extra elongation due to that m mass, that will be mg by k. in our question, it's given that the elongation due to weight alone was 2 and the total elongation was 10. So this part was 2. So this part will be 8 because the summation is given as 10. So from these two, we can easily find the value of m just by dividing, and it's coming out equal to 100. And its unit will be grams because we have kept 50 in grams. So if we solve the equations using this 50, that is in grams, we'll get m in grams only.